This video will teach you how to do reflections over the line y equals x and y equals negative x. To start, we need to figure out where the line y equals x actually is. And if you think about it, y equals x, it's an equation. So if I choose y as 2, then my x has to be the exact same thing because they're equal, so it's also going to be 2. Or if I choose a y of 1, x is also 1. Or if I choose a y of 0, it's also 0. And so if I fill in this table, I would end up with matching numbers on both sides. And when I go to graph that, here's where the line appears. And while you don't always need to draw it in, it does help to know where it is. Because like a lot of our other problems, if you imagine folding your paper in half there, your shape should end up laying on top of itself. The rule for a reflection over the line y equals x is going to be x comma y will switch to y comma x. So they're just going to switch spots, and you can see in the example below, my first point is -1 comma 2, and when I used the rule, all they really did was they just flipped places, and now it's 2 -1. So in the first example, I actually am not going to have to graph it all. It just wants me to apply the rule to the set of points. So it says reflect triangle PQR over the line y equals x to find triangle PQR prime. So my first points, I have 1 comma 2, and so we're just going to imagine switching those. So P prime is going to be at 2, 1. Q is at 0, 0, so again, imagine flipping those. It's still 0, 0. And the last one, R, to find R prime, remember, again, I'm switching those, so I'm going to have -8, 5. This time we need to find where the line y equals negative x is, so I'm going to choose some x values, and I'm going to kind of use my equation to fill in the y side. So if y equals negative x, so if the x is -2, if I had -2, it'd be +2. If I had -1, it would be 1. If I had -0, well, that's really just 0. Then if I have these 1, 2, and 3, if y equals negative x, then I need to put a negative in front of those. And so really, they're just going to be opposite signs. If I start to plot those, this is the line that appears. And so again, we don't have to draw it in every time, but it gives you a good idea of where your paper would be folded if we were folding it. The rule for a reflection over the line y equals negative x is this time, just like before, they're going to switch places. But they also have these negatives in front of them, which just means change sign. So if you look down here, these two switched places, and then they also changed signs. So the 2 was last, now it's first. It was positive, now it's negative. The -1 was first, now it comes second. It was negative, now it's positive. So they flip and they switch signs. In this example, it wants me to reflect across the line y equals negative x. This time I do have a picture, so I am going to write down the coordinates first. So if you look at t, it's at -1, 2, 3, 4, so -4 and +4. Y is at 0, 2, and I is at -5, 0. When I use the rule, they're going to flip spots and switch signs. So if I flip the first one, I would get 4, -4, and then I have to go back and change my sign. So the first one will become negative, the second one is positive. For y prime, if I switch their spots, I would get 2, 0, and this was positive, so it becomes negative, and 0 is just going to stay the same because there's no -0. And same thing for I prime, I'm going to switch their places, and then their signs, again, 0, there's no -0, so it'll stay the same, but -5 will become +5. And then if I graph those, T actually stayed in the same spot. Y prime moves down here. And I prime is at the top. And it can be kind of hard to see how that transformation worked. So let me just highlight the line for you so that you can see, if you were to fold your paper, how it really does lay back on top of itself.